So now, so then what?
Then we take 3 1/3 moles times our coefficient, or our ratio of so it would be 3 1/3 moles times 1 mole of, it would be 17 over 1 mole of NH3.
Okay, the key point is that we're not in our target units yet. We need to go from moles to grams. So I should cross this out now because I decided this is not what's actually going to be working. Now I stopped short here without getting to the grams, because we can find the limiting reagent just in moles or in grams. Well, there's no point taking this all the way to grams when this isn't going to happen anyway. It sounds to me like you got the right next conversion ratio. We need to get rid of the moles of ammonia and replace this with grams of ammonia. Well, this is 17 grams per mole. Okay, so let's go back to calling 3 1/3 10/3. So let's do that calculation. It's 10/3 times 17. Yep, but we need to simplify that. 1 is 170 over 3. Right.
It's like 56.
Yeah, close enough. 56 grams. Again, it's safest to do things on paper, so we avoid making mistakes. So what was the answer to my question? The whole question?
56 grams of NH3.
Yeah, this is our starting point, our stopping point. We want to find the 56 grams of ammonia. Okay, so the habit we have to start getting into is extending our unit conversions. There's no need to do the calculations up front. Unless you see a good reason to, but our default should be to write down all the conversions before we do the calculations. So again, you want to make sure when you're on your scratch paper that you start on the left, so there's plenty of room to write all of that stuff out. This is pretty similar to the method that we used before. So how do you find the limiting reagent? Well, now we have two methods. You can figure out how many grams of product we can get from each starting material and see which one is less, or you can figure out how many moles of product you could get from each starting material and figure out which one is less. Because if you get fewer moles of product, you would also get fewer grams of product. So either of those could tell you what the limiting reagent is. In this case, it seemed convenient to stop with the moles when we were trying to figure out our limiting reagent. Okay, this is a very important type of technique then that we have to use again. Now the trap here is, again, a naive person would say, gee, we got way more nitrogen than hydrogen. So, or wait, no, the naive person would be right, wouldn't they? The naive person would say that we're going to run out of hydrogen first. Well, they can't just assume that, but it turns out that in this case they're correct. But you can see it's not obvious anymore, because not only do we have to, because for one thing we have to convert from grams into moles. That would really throw our intuition off. So it's best to work this out on paper rather than trying to guess who's going to be the limiting reagent. It's true. Yeah. Okay. It's true that it seems like we have a lot more nitrogen, but this is misleading because it takes many more grams of nitrogen to make a mole of nitrogen. So the difference here is not as big as it seems. That was the point that I wanted to make.